This is a review of the fuel contaminated backfill problem from your midterm exam. Here's the text of the problem. The key concept that you need to understand in order to solve this problem is that it's just a regular weight volume problem with one small twist, and that is, instead of the soil having water in it, it has petroleum in it, which has a specific gravity of 0.81, as opposed to water, which has a specific gravity of 1. With that in mind, we must start, as we always do these problems, with a three-phase diagram. So here's a typical three-phase diagram with soil, water, and air. But I'm going to scratch out the water part and enter P for petroleum, since that's what we have as a pore fluid. And I'll put volume on the left in cubic feet and weight on the right in pounds. Well, we know the total volume that was specified in the problem statement is there's 5,000 cubic feet. So we'll put that in for the total volume. And then we can calculate the total weight. Total weight simply equal to the total volume, 5,000, times the unit weight of the soil, 109 pounds per cubic foot, which we know. So that gives me 5.45 times 10 to the 5th pounds. I'm going to write the 10 to the 5th at the top of the column and just write the 5.45 in the side of the column. So I have 5.45 times 10 to the 5th total pounds of soil. Next, we got to compute the weight of the solids. The weight of the solids, we still have the same equation that the weight of the solids is equal to total weight divided by 1 plus the water content. In this case, we were given that the water content, or in this case, the petroleum content was 12.2%. So the weight of the solids is simply 5.45 divided by 1 plus 0.122. Notice that I have to use the decimal form of the water content. So I calculate those numbers out, and that'll give me 4.86 times 10 to the 5th pounds, and I'll enter that in my phase diagram. And now I could compute the weight of the petroleum, which is just the difference between the total weight and the weight of the solids. And if I do that little subtraction, I'll find out that there's 0.593 pounds of petroleum times 10 to the 5th, so I'll put that in my phase diagram. And now I've completed the entire weight side of the phase diagram, and I just need to complete the volume side. And I'll start on a new page to complete the volume side. So here's my three-phase diagram with all the quantities I'd already computed. I've got the total volume and all the weight side filled out. So the first thing I'm going to do is just go ahead and compute the volume of the petroleum. So we know the volume of the petroleum is going to be equal to the weight of the petroleum divided by the unit weight of the petroleum. And the unit weight of the petroleum is not equal to the unit weight of water. It's going to be equal to the specific gravity of the petroleum. That's G sub SP, I noted here, times the unit weight of water. We were given that the specific gravity of the petroleum contents we're dealing with was 0.81. So the volume of the petroleum is simply equal to the weight of the petroleum divided by the specific gravity of the petroleum times the unit weight of water. So when I do that calculation, I'll find out that there's 1,170 cubic feet of petroleum. So I enter that in my phase diagram. Now I could stop here because the question being asked was just what is the total volume of the petroleum, but just for the sake of being complete, I'm going to calculate the volume of the solids, and the volume of the solids is simply equal to the weight of the solids divided by the unit weight of the solids, which is equal to the specific gravity of the solids, 2.65. That was given to you, times the unit weight of water. And if I run those numbers out, I'll find that there's 2,930 cubic feet of solid material. So now I have a complete phase diagram, I have all the quantities I need, and we've solved the problem. So to quickly summarize, the answer to the problem is that the volume of the petroleum is 1,170 cubic feet. More importantly, the key point to solving this problem is to recognize that it's a regular weight volume problem with just one small twist, and that's that the pore fluid is oil, which has a unit weight that's equal to 0.81 times gamma water instead of water. If you understand that, the problem is straightforward and just like any other weight volume problem. I hope this helped.